All right, we got Darian there. Now, because Darian is off, I want you to imagine that Darian's head has a mass of 8 kilograms. Because Darian is Darian, Natalie throws a 2 kilogram spit wad at him.
You gotta draw me up there too.
No good. So he throws a 2 kilogram spit wad. Dripping saliva. At Darian's head. Now, the spit wad is moving at 100 meters per second. What is going to happen is the spit wad is going to impact Darian's head and stick.
Yeah.
They will act as if they were one thing. Darian has no body, or at least that's what his ex-girlfriend said. So literally it's just the head acting. Does that make sense to you? So we're going to calculate the velocity of head and spitball after impact. Well, according to this, the total momentum of a system doesn't change. So we know that momentum before will equal the momentum after. Does that make sense to you?
Yeah.
So does this head have any momentum if he's at rest?
No.
So what is the only thing that I have to worry about in terms of momentum? The spitball. What's my formula for momentum? Mass times velocity. So it's going to be 2 times 100 equals 200, and then my unit is kilograms, meters, over seconds, because you just multiply the units too. Is that clear to you? So, according to the law of conservation of momentum, that's the momentum also afterwards. Well, now that the spit wad has impacted this huge dome, what is the combined mass of the spit wad and the head? 10. I don't know the velocity yet, but I can solve for it, can't I?
Okay, wait. How'd you?
Well, how much is this way? How much is this way? And if they stick together, don't they act as if they're one object? Does that make sense, everybody? So if I divide both sides by 10, then literally the velocity of head and spit wad combined is going to be 20 meters per second. Does that make sense to you? Now, we also see this type of problem with train cars. Because train cars have the ability to couple. Please go ahead and pull your earbud out, son.
Oh, I'm not listening to anything.
Please go ahead and pull your earbud out, son. Thank you. In this situation, I want you to imagine that we have 2 identical train cars. And what's going to happen is this train car is going to slam into this train car. And they're going to stick together through this couple. Does that make sense to you? This one is not moving, but this one is. And it's moving how fast? So what do we